You heard in the previous lesson the two words current and voltage.
What is current? What is voltage? How can we measure them? These questions will be answered in this lesson.
Electric current is very similar to a flowing river that flows from one spot to another. The electric current is the quantity of electricity that passes through the electric circuit. This is the dry cell that is the source of the electric current. This is the lamp that is the component that needs this electric current to glow. Let's make a closed electric circuit using the wires. The lamp glows. These arrows represent the movement of the electric current. I'll now reverse the dry cell and put the positive pole to this side and the negative pole to this side. What do you see? The direction of the electric current is also reversed. What does this mean? This means that the electric current moves in one direction, from the positive pole of the dry cell to the negative pole of the dry cell. The amount of current that passes through the electric circuit is 0.9 A. A is the symbol of ampere, that is the SI unit of the current, where the intensity of the current is symbolized by I. Then I equals 0.9 A. That means the intensity of the current equals 0.9 ampere. The SI unit of current is ampere, where it is symbolized by A. Do you think that there is another unit of current? Yeah, it's milliampere. That is symbolized by MA. To convert from ampere to milliampere, we have to multiply by 1000, and to convert from milliampere to ampere, we have to divide by 1000. How can we measure the intensity of the electric current? We measure the intensity of the electric current using an instrument called ammeter, where this instrument is made up of two terminals, positive and COM. In order to use this instrument, it must be connected in series. In series means that all the components in the electric circuit are connected end to end. Here, there is an electric circuit of a dry cell, two lamps that are connected end to end, so they are connected in series. If the switch is closed, then you'll obtain a closed electric circuit and the lamps can glow. Thus, the current passes through the circuit. To measure the intensity of the current, we have to use the ammeter. Let's connect the ammeter and the electric circuit. Cut the wire and connect the ammeter in series. But take into consideration that you have to connect the positive terminal of the ammeter to the positive pole of the dry cell and COM to the negative pole of the dry cell to give a positive reading. The intensity of the current is 0.6 ampere. If you connect the ammeter in the opposite way, by connecting COM to the positive pole of the dry cell and positive terminal of the ammeter to the negative pole of the dry cell, you'll get a negative reading minus 0.6 ampere. So, the correct connection of the ammeter is to connect it in series where the positive terminal is connected to the positive pole of the dry cell and COM to the negative pole of the dry cell. This is the symbol of the dry cell, the negative pole and the positive pole. This is the symbol of the lamp. This is the symbol of the ammeter. This is the symbol of the closed switch, and these are the connecting wires. We put the COM terminal here because it's the side of the negative pole of the dry cell. And we put the positive terminal of the ammeter here because it's the side of the positive pole of the dry cell. Because it is connected in series and the positive terminal of the ammeter is connected to the positive pole of the dry cell and come to the negative pole of the dry cell.
While the connection of the ammeter at this circuit is not correct because the positive terminal of the ammeter is connected to the negative pole of the dry cell and COM is connected to the positive pole of the dry cell, so the ammeter will give a negative reading. The connection of the ammeter in the final circuit is not correct because it is not connected in series.